Hello, good morning. Any doubts if you have from previous classes? Yes, go ahead. Sorry, which experiment? In situ experiment. Okay. So coach, what is your question? In situ का मतलब you are doing things exactly where you have gone to. So in this particular in situ is a English word. इसका मतलब होता है कि हम किसी natural जगह पे ही हम कुछ कर रहे हैं. जैसे environment में you'll be taught about in situ conservation. इसका मतलब होगा कि मान लो if I have to conserve some plants and some animals, then I'm not bringing them to some special place like zoo or some botanical garden. I'm conserving them in their own natural habitat. In this particular case, in situ experiment will mean that I'm not bringing back sample from moon to earth and then I'm conducting experiments on that sample. I'm conducting experiments then and there on the moon itself, and then I'm sending the experimental data. That is the meaning of in situ experiment in this particular context. Okay. Ex situ means अगर ex situ होता है यहाँ पे, so that would have been that we are bringing sample or we are conducting that experiment somewhere else. Any other question? Yeah. एक ही चीज ये नहीं है, जैसे आप कॉन्टेक्स्ट बताओ. ओके हाँ, तो पोटेंशियल इम्पैक्ट यहाँ पे सेम चीज है. ठीक. हाँ, वी बेसिकली हैव टू टॉक अबाउट एप्लीकेशंस हियर. सब सेम है. ठीक है. Significance भी सेम है. So impact, potential impact, significance, all of those things. If you are asked a question that what will be potential impact of something or impact of something or significance of something, more or less same points will be there. Science tech में at least यही होगा. बाकी subjects में हो सकता है थोड़ा सा meaning change हो जाए, but science tech में यही होगा. Any other question if you have? Please explain about halo orbit. I haven't explained halo orbit. I'm going to do that in today's class. Yes, go ahead. Okay, now that's okay. ठीक है. So what is? I gave you a question that there is a probe of NASA called Parker probe, and I told you that Parker probe as of now is inside solar corona, not photosphere, very far away from photosphere. In fact, it cannot sustain photosphere, but it is part of solar corona. And my question was that how does it survive solar corona? Because I told you in last class that the average temperature of solar corona is about 1.5 million degrees Celsius. It can be higher than that also. Anyone who will try to answer this question? That will not help. So even if it has 4.5 inch thick carbon fiber, it should melt at few thousand degrees Celsius. And I'm telling you the temperature is 1.5 million degrees Celsius. So it goes without saying that इसका जो outer layer है, that is made from materials which can sustain very high temperature. That even if their temperature increases to, let's say, 1000, 1500 degrees Celsius, 2000 degrees Celsius, it is not going to degrade. Yes, go ahead. Perfect. So that is the perfect answer. So the answer is actually quite simple, that how we use these two words heat and temperature interchangeably. Just because I am in a zone where temperature is very high does not mean that immediately my temperature is going to also be very high. It depends upon a lot of parameters. Fundamentally, what is my temperature? It depends upon how much heat I am receiving, or if my temperature increases or decreases. It ultimately depends upon that am I losing energy from the surrounding and am I gaining energy from the surrounding. Now we know that if my temperature is less than the surrounding, I'm going to gain energy, and if my temperature is more than the surrounding, I'm going to lose energy. This is a fundamental law of thermodynamics all of us have studied, that heat always flows from higher temperature to lower temperature. But just because heat flows does not mean that I have the temperature of my surrounding. जैसे in winter season all of us act like mad scientists, how much cold water, how much hot water, perfect temperature ki hum naha sake. We do that in winter season. So imagine a situation that you have like half bucket of water at, let's say, 4 degrees Celsius. And just by pouring one mug of water, which is, let's say, at 90 degrees Celsius, does not mean that this entire bucket also comes at 90 degrees Celsius. I have to keep pouring lot of water, and even then the temperature will be, let's say, 30 degrees Celsius. So it's not that if you are in contact, or if you are in, let's say, a region where temperature is very high, immediately your temperature is also going to be exactly that. It depends upon that जो particles हैं, जो आपका surrounding है, how much energy they can transfer to you. So Parker probe is in corona, and solar corona is a very scanty region. What it means is that even though there are particles, but the particle density is very less. Now particles have very high energy, and because of that, I told you temperature has something to do with inherent energy of a system. So particles have very high energy, and because of that, temperature is very high. But the concentration of particle is not very high. So inside solar corona, the amount of particle this probe will come in contact with, yes, it will transfer heat energy, but that heat energy will be not a lot. And in any case, its temperature will increase up till, let's say, 1500 degrees Celsius to 1000 degrees Celsius. So just because Parker probe is in a zone where temperature is, let's say, 1 million or 1.5 million degrees Celsius, does not mean that the probe in itself also reaches to 1 million or 1.5 million degrees Celsius. At the same time, it will not survive even a second in photosphere, because photosphere is so dense that immediately its temperature is going to increase up to a few thousand degrees Celsius, and it is going to melt. So in any case, Parker probe will stop functioning many thousands of kilometers and few million kilometers before photosphere, because as you keep entering inside deep and deep into solar corona, the particle density keeps on increasing, and the temperature will rise so much that it is going to melt away, and all of its devices will stop functioning. It cannot maintain contact with Earth stations. But from inside solar corona, Parker probe has sent some videos that what it looks like inside solar corona. And it's just very bright particles which you can see here and there. So now if you go and on NASA YouTube channel, you'll find this video that what Parker probe has sent till now. So the fundamental point here is that do not confuse between the term heat and temperature. Temperature determines the direction of heat transfer, but system का temperature इस बात पे depend करेगा that how much heat actually has been transferred, and that depends upon lot of things. That depends upon जो surrounding है, उसका temperature क्या है, yes, that will play a very important role, but how much heat energy the surrounding has, that also will play a very important role. So if particles are very less in the surrounding, then the heat energy is also very less. Even though the total temperature is very high, the total energy is not very high, and because of that, Parker probe का temperature will never increase, और जब तक ये function करेगा, will not increase beyond 1500 to 1000 degrees Celsius, and there are a lot of materials which can sustain such high temperature. So the fundamental reason is that do not confuse between heat and temperature. जैसे I sent a satellite into space, you'll come across this term that this satellite is crossing a point or will come across a point where temperature is, let's say, minus 150 degrees Celsius. Does that mean that this satellite immediately will come at minus 150 degrees Celsius? Not at all. Its temperature will reduce, but not at all. It will not be anywhere close to minus 150 degrees Celsius. And similarly, when you come across a point that this particular spacecraft is crossing a point where temperature is 230 degrees Celsius, positive 230 degrees Celsius, does not mean that immediately its temperature will be positive 230 degrees Celsius. Right? So how much time you spend in a surrounding, what is the energy of the surrounding, what is the temperature of the surrounding, all of that will decide that what will be the temperature of system, right? What will be the temperature of the object I'm describing here. Yes. The question is, and that's an interesting question, the question is that can sunspots affect climate on Earth? Earth's climate fundamentally depends upon how much heat you are receiving from sun. If heat received becomes less, then it will lead to cooling. If heat received increases, it will lead to warming. Very simple, fundamental relationship. In past, for example, Earth has witnessed glacial cycles. Those glacial cycles can occur because of many reasons. And one of that can be that if the amount of heat energy we receive from sun has decreased. Why has it decreased? Maybe because sun is not emanating that much of energy. And why is it not doing that? Maybe because sunspots are much more extensive on the surface of the sun. So to answer your question, yes, technically it is possible that sunspot can affect Earth's climate system, because whenever sunspots are there, and particularly if their area is very large, then it means that the net amount of heat energy radiated by sun will decrease a little bit. And immediately it will not cause an impact, but if it goes on for, let's say, few hundred years and 1,000 years, then the impact will become much more visible. So technically the answer is yes, but practically that impact is actually quite negligible, so that we neglect that in, like, let's say a decade or 20, 15 years, 20, 30 years. Any other question if you have? दैट्स अ गुड क्वेश्चन, और हम आंसर करेंगे अभी आज के क्लास में। आज के क्लास में हमारा पूरा फोकस यही होगा कि हमने आदित्य L1, मैं शुरुआत यहीं से करूंगा कि आदित्य L1 को हमने L1 पे भेजा ही क्यों है, वाई हैव वी सेंट आदित्य L1 एट L1 पॉइंट, लाइक व्हाट स्पेशल पर्पस डज इट सर्व देयर। आई एम गोइंग टू आंसर दैट क्वेश्चन। ओके, यस, बियॉन्ड, ओके, या, okay, that's also a very good question, and that has to do with the nature of vector force. So I will try to answer this question, but if you do not understand vector mathematics, then you'll not be able to appreciate it. So in fact, this question I don't think is important for this class. Come after the class, and I will tell you that the vector law, that why the 2 points L4 and L5 are not on the line, but they're actually perpendicular to this. The question he was asking is that why L4 and L5 are not on a straight line. So L1, L2, L3 are a straight line, but L4, L5 are perpendicular. So how can the L4 and L4 5 point can be actually beyond the plane? जो अर्थ सन का जो प्लेन है सेंटर का, how can it be outside that plane? So there is a very good reason how it can be outside the plane system. What is the reason behind formation of Van Allen radiation belt? I can briefly tell about that also. So Van Allen was a scientist who figured out that around Earth's magnetic field, in the Earth's magnetosphere, a lot of solar particles are struck here. So Earth will not allow them to move out, but will also not allow them to enter into lower atmosphere. So they extend across few thousands of kilometers, but in this few thousand of, and there are two belts on both sides of Earth, and you have concentration of solar particles very high into these places, and these places are called Van Allen radiation belt. Understanding of Van Allen radiation belt is important for two reasons. That we do know that these radiation belts, they can adversely affect our satellites, so we would want to avoid that. Or even if they are not adversely affecting, they will definitely cause errors in their calculation. Particularly, let's say I have a GPS satellite or communication satellite, so we should be ready to rectify that error. So, and Van Allen radiation belt, if let's say an astronaut gets to live in a zone where the Van Allen radiation belt is present for very long, and if an astronaut is exposed to such radiation for very long, then that can be harmful for body. So simple, Van Allen radiation belt, you have these two belts on both sides of the Earth, and these two belts are created because of Earth's magnetic field. कि जो अर्थ का magnetic field है, it has allowed few solar particles, and by the way few का मतलब यहाँ पे trillions of solar particles है, so trillions of solar particles stuck on both side of the earth. And by the way this belt is not as such, ऐसा नहीं कि static belt है, बहुत dynamic belt है. And there are also times where you will find a third belt emerging for a temporary period, but more or less these two belts remain on both sides of the earth all the time. If you want to write it down आप लिख सकते हो. Van Allen radiation belt, Van Allen radiation belt, Van Allen radiation belt is a zone of energetic charged particles, is a zone of energetic charged particles, zone of energetic charged particles, most of which originate from the solar wind, most of which originate from the solar wind, that are captured and held around by earth, that are captured and held around by earth due to its magnetosphere, due to its magnetosphere, due to its magnetosphere. Earth has two such belts. Earth has two such belts. And sometimes others may be temporarily created. Sometimes others may be temporarily created. तो यहाँ पे जो satellites होंगे, they will require adequate shielding. For example, we talked about that golden foil around satellites. That golden foil will come in handy so that our satellites' electronic components are not adversely affected because of this belt. So when we launch satellites, we have to ensure that they are not affected by Van Allen radiation belt. Give the next heading Lagrangian point. Lagrangian point and halo orbits. Write down few things first. I will explain this later. Lagrangian points are positioned in space. Lagrangian points in position in space. Position in space where an object with small mass, small mass can find required centripetal force, required centripetal force to have a stable orbit, However, the centripetal forces due to combined gravitational effect of combined gravitational effect of two much heavier bodies. Combined gravitational effect of two much heavier bodies. For example, Earth-Moon system can have 5 Lagrange points. Earth-Moon system, Sun-Earth system, Sun-Jupiter system. For example, Earth-Moon system, Sun-Earth system, Sun-Jupiter system. All of these points can have, all of these two systems will have 5 Lagrangian points. And around those 5 Lagrangian points, I can find a stable orbit. But this stability is not because of either one or the second. It is combined effect of both of the objects. So if I place something in Earth-Moon system at these Lagrangian points, then this very smaller object can find a stable orbit because of the combined gravitational effect of Earth-Moon system. And same is true in case of Sun-Earth system. So we are much more interested in Sun-Earth Lagrangian point, right? So you can give this heading, Sun-Earth system. All of these two-body systems can have 5 set of Lagrangian points. All of these systems can have 5 set of Lagrangian points. 5 set of Lagrangian points. Example के बाद आप लिख सकते हो, all of these systems can have 5 set of Lagrangian points. Orbit around these points, write down, orbit around these points is called halo orbit. Orbits around these points is called halo orbit. Orbit around these points is called halo orbit. Is called halo orbit. So you have Sun, you have Earth. Because of Sun and Earth, I can find 5 Lagrange points. This point here is called L1 between Sun and Earth. This point is called L2 behind Earth. This point is called L3 behind Sun. And this point is called L4 and L5. So you have 5 of these points, and around 5 of these points you get. So for example, I do not have to keep something exactly at L1. This is also very important. I do not have to put something exactly at L1. I can have an orbit, I can have a satellite around L1. And even if there is nothing at the center, it is a point, but still I can have a satellite hovering around this point. And for this motion, the required force will be because of the gravitational effect of both Earth and Sun system. So this is the beauty of Lagrange point, that even if there is nothing at the center, I can find an orbit. But I cannot actually draw this orbit exactly what it will look like on a board, because think about it. As Earth rotates around Sun, so will all these 5 points. In 5 points कोई fix तो है नहीं, because Earth is revolving, sorry, not rotating, but Earth is revolving around Sun. So these 5 points are also revolving around Sun. So as these 5 points revolve around Sun, and I have a satellite which is revolving around the point, so this orbit, even in Sun-Earth system, will not be a 2-dimensional orbit. It will be a 3-dimensional orbit, and it will look quite complicated. I do not have to draw this. There is a very good animation available on YouTube, which I'm going to show. But first, let me tell you what you asked, that why L1 point. So let me, in fact, tell you a problem in solar observation. If I send something around Earth, मान लो that I have sent a observatory, let's say Aditya mission, जो in fact ISRO का जो पहला plan था, it was called Aditya mission, that was abandoned, but that mission was that let's send a solar observatory into LEO. That would have been much easier, that let's send something, let's say at the height of 500, 600 kilometer. But then there is a problem, because this satellite or this spacecraft will be bound to Earth. Now let's say it is revolving around Earth in, let's say, 2 hours. For 1 hour, Earth is between this satellite and Sun. Think about it. So Sun is somewhere here in the sky. As long as this satellite is revolving here, it can observe Sun. But the moment it comes behind Sun, Earth is causing an eclipse for it. जिस तरीके से कैसे Earth and Sun के बीच में moon आ जाता है, that is eclipse. So in this case, for this satellite and Sun, Earth is in between. So Earth is causing an eclipse for this satellite. So half of the time, in every of its orbit, half of the time, it will not be able to observe anything about Sun. That's not good. I am trying to send solar observatory, and this solar observatory is not working 24/7. In fact, it is only working half of the time, 12/7. I do not want that. I want the solar observatory to work 24/7. I want an observatory which can look at Sun all the time without any type of eclipse. So let's go to solar orbit then. Why don't we send something around Sun? An independent orbit around Sun. The same way planets revolve around Sun, we can send a probe also which can revolve around Sun. Then there will be a problem, because if I send something very close to Sun, it is not bound by Earth anymore. I have found a stable orbit around Sun. Now a problem will occur, that if this object is closer to Sun with respect to Earth, this is Earth, and I send something from Earth into, let's say, a solar orbit. A solar orbit is called heliospheric orbit. We use a word for solar orbit. All planets, for example, revolve in heliospheric orbit. So let's say I send a probe into a heliospheric orbit, not at all affected by Earth's gravity, only and only affected by Sun's gravity. But because it is closer to Sun, it is going to revolve much faster. Remember, I told you that the closer you are, हमने discuss किया था, केपलर का एक fundamental law था. केपलर ने जब planetary motion describe किया था, when he described planetary motion, one of the conclusion was that the closer you are going to revolve much faster. For example, Mercury revolves in about, I think, 3 months, if I'm not mistaken, less than 3 months, 88 days. And Venus revolves in 200 few days. Pluto, which is by the way not a planet as of now, but Pluto has not completed even one revolution since its discovery, and it was discovered about 40 years ago. So it has not completed even one revolution around Sun in 40 years. So the farther you are, your revolution period will be less. If you are closer compared to Earth, you are going to revolve much faster. So this probe will reach here, and Earth has reached only here. But what benefit this will then give me? How am I going to collect that data? So I've sent a probe which is collecting data about Sun, but I cannot receive that data about Sun. That's also not very useful. I want a continuous stream of data from this probe without any type of eclipse. I have to do both of those things. If I send something into LEO, then yes, I will be receiving data all the time. But half of the time, this probe will not be working. If I send something into an orbit around Sun, independent of Earth, then it is going to revolve much faster than Earth. And I will not be, very soon my synchronization will be lost, and I will not be able to receive any data from this probe. And that is why Lagrangian point. So Lagrangian point, at Lagrangian point, there is a very powerful pull from Sun. This Lagrangian point L1, by the way, is 1.5 million kilometer from Earth, very far away. Even high Earth orbits will be 36,000. Let's say the farthest earthbound orbit is 45,000 kilometer. But this is 1.5 million kilometer, 3 times more than distance of Moon. Moon is at 384,000 kilometer, not 3 times, but 2.5 times sort of. And at 1.5 million kilometer, I cannot ignore Sun's gravity anymore. In fact, Sun has a very powerful impact on this. But this impact is neutralized a little bit by Earth. And because of that, as Earth revolves around Sun, this object revolves exactly in the same time period. So जो L1 point है, because L1 is bound to Earth Sun system, even though L1 point is closer to Sun with respect to Earth, L1 point will complete one revolution in 365 days, same as Earth completes one revolution in 365 days. But the best part here is that now imagine that at this, here you have Sun, I have a probe here, and this probe can observe Sun all the time without any eclipse from Earth, and it can all the time also send data to Earth. So I have a continuous line of communication with respect to this particular probe. So that is why L1 point was chosen. And ऐसा नहीं है कि ISRO has done it for the first, sorry, any space agency has done it for the first time. L1 point is actually quite popular for solar observation, and there have been past probes also, but the number is not very large. I think only one other mission you should know about, which already exists around L1 point. There is a mission of NASA called SOHO mission, Solar and Heliospheric Observatory. That is also a solar observatory launched by NASA a few years ago. And Aditya is a new addition around L1 point. So why L1 point? Because at L1 point, the sun's attractive pull of this particular spacecraft is little bit neutralized by Earth's attractive pull towards it. What it means is that this orbit, or this spacecraft, even though it is revolving around Sun, it is not an independent motion. It is still bound by Earth. So all the time it is between that Sun-Earth system. As Earth revolves around Sun, so does L1, and so does this probe which I have launched around L1 point. That is the beauty of Lagrange point. So L1 point is very, very useful for solar observation. But so is L2 point, not for solar observation, but for something else. Let me complete this. I will give you enough of time to ask questions. Let me complete this. So now go to the L2 point. This is L1. Now L2 is behind Earth, and L2 distance is also 1.5 million kilometers, but in the opposite direction. Now something which is revolving away from Earth compared to Sun, it is going to revolve slower than Earth. For example, Mars ka jo revolution hai, that will clearly be more than 365 days. But because in this case, the attractive force is in the same direction, that Sun is attracting, but even Earth attraction coincides with Sun. So the required centripetal force is not only because of Sun, it is also because of Earth. So a probe which I have sent around L2, this is also going to revolve in 365 days. Now why this is useful for me? This is quite useful if I want to launch some sort of telescope, some sort of space observatory. One of the most famous telescope, which was launched a few decades ago, 25 years have passed now, is a telescope called Hubble telescope. Hubble telescope was launched by NASA, one of the most powerful telescopes and one of the most important object in the sky. Even today it functions because it has allowed us to observe universe like never before. That we have really good understanding of stars and galaxies, and the very first stars and galaxies in fact. But even Hubble telescope is in an Earth-bound orbit. It is in LEO. It is at the height of about 450-500 kilometers. So Hubble telescope, as it revolves around Earth, let's say this telescope has to observe or collect light from a particular galaxy in the sky. So all the time it is orienting itself to the particular galaxy. And by the way, whenever a telescope functions like that, then it aligns itself for few hours. It collects light for few hours. It's not just for a minute or two. It does that for few hours. But even Hubble will be adversely affected because of Earth, that this galaxy is somewhere in this part of the sky. Hubble is revolving around Earth, and Earth will come in between, and Earth will cause an eclipse. If I send something at L2 point, now L2 point is 1.5 million kilometers away. So forget about Earth, even Moon will not come into its path. Now this telescope, as it revolves around L2 point, this telescope can observe the night sky all the time without any type of eclipse by Earth or Moon. And because it is revolving exactly in 365 days, it is going to all the time send data back to Earth. L2 point, as of now, is home to the most powerful and sophisticated telescopes ever made by human beings. There is a telescope called James Webb Space Telescope. And this was launched just 3 years ago. It was launched in 2021 or 2022, in fact, if I'm not 21 or 22. And this is the largest telescope and one of the most sophisticated telescope, much powerful than Hubble, by the way. And already it has only functioned for now last 2.5 years, but already the amount of information it has provided us about universe is challenging our existing knowledge of astronomy. That the type of data we have gathered with Webb telescope is actually asking us that we need to relook at the how we think universe functions. This telescope also may have found traces of life on another planet. Although it has not been confirmed, maybe in next few months or few years it will be confirmed. But this telescope has found traces on exoplanet, a planet which is not even part of solar system. All planets which are not part of solar system are called exoplanets. So it has found that there is a chance that on some exoplanet there is some life possible. So this is the type of sophistication we are talking about. And the Webb telescope that is around L2 point. So L2 point is also quite busy. Many more missions have been launched at L2 point, but the most famous one is James Webb Space Telescope. So L3 point hai, that is not very useful because L3 point will always be behind sun. So even if I get to send something here, I don't know for what purpose we will send it at L3 point, but let's say that we get to send something around L3 point, but it will always be behind sun. How will we collect data from that? So L3 point, even though theoretically it does exist, practically does not have any utility. But L1 and L2 point, they do have a lot of utility. Before I make you write anything, I'm going to take questions also, but I want you to watch a very small animation that NASA का जो James Webb Space Telescope का जो official YouTube channel है. If you go to that YouTube channel, they have this very nice video that how Webb telescope orbit looks like, and you have to imagine the same thing just between Sun and Earth for Aditya L1 orbit. This link is available on the PPT which I have got uploaded. So let's slow down the speed. You can imagine the same thing happening or similar thing happening, but just between Sun and Earth system. So this is at L2 point, जो Webb telescope है, James Webb Space Telescope, that is at L2 point. But Aditya L1 mission is between Earth and Sun, revolving around L1 point. So this telescope is revolving around L2, but L2 in itself is revolving around Sun, bound in Earth-Sun system, and the actual orbit will be a 3-dimensional orbit. So this is what I meant, that why I cannot draw this orbit on board, because the actual orbit is a 3-dimensional orbit. Now you can imagine the same thing happening at L1 point, and that will be the orbit of Aditya L1 mission. You can watch it again, that you have telescope revolving around L2, that is James Webb Space Telescope. And as Earth revolves around Sun, remember the Lagrange points are bound in Earth-Sun system, so these points are also going to revolve around Sun. So essentially this is also a heliospheric orbit, but the required centripetal force is not because of Sun only, it is the combined effect of both Sun and Earth system. What were you asking? You had a question. मेरा पूरा point यही था कि as Earth revolves, the points are going to change. Compared to even in Sun-Earth system, the points will change because Earth is not fixed. Nothing is fixed in this universe. So Earth is not fixed, and if Earth is not fixed, I can show you another animation. This should answer your question. that think of sun, think of earth, that yellow sphere, sun, that blue sphere, earth. And as earth revolves around sun, you find this 5 zone of stability, and that 5 zone of stability, we call it Lagrangian point. So as earth revolves around sun, these points are also changing. Okay. Any other question if you have? Write it down. Meanwhile, if you have any question, ask after noting it down. Write down in bullet points. For sun earth system, for sun earth system, earth system, L1 point, L1 point, I hope all of you made the diagram which I had made on the board. L1 point is between earth sun, is between earth and sun. 1.5 million kilometer, 1.5 million kilometer from earth, 1.5 million kilometer from earth. ये अभी भी इतने distance होने के बावजूद, despite such a large distance, it is only 1% of the distance between earth and sun. Earth and sun's average distance is 150 million kilometer. So compared to 150 million kilometer, 1.5 is only 1% of the distance. Write down. This is ideal for solar observation. This is ideal for solar observation. This is ideal for solar observation. Solar observation. As a probe can continuously monitor sun. Probe can continuously monitor sun. Monitor sun. Without any eclipse from earth or moon. Without any eclipse from earth or moon. Without any eclipse from earth and moon. And all the time capable of sending data back to earth. Capable of sending data back to earth. Write on the next bullet point. L2 point is also 1.5 million kilometer. L2 point is also 1.5 million kilometer from earth. But in the opposite direction to L1. L1 में आप एक लाइन लिख सकते हो. L1 में हम एक लाइन ऐड कर सकते हैं that NASA SOHO mission is placed here. So Aditya is also placed here. But even before that, you have a mission of NASA SOHO, Solar and Heliospheric Observatory, in the L1 point. L1 point के description में you can mention that NASA SOHO mission is placed here. Now coming back to L2 point. L2 point is suitable for astronomy. We're talking about L2 point. L2 point is suitable for astronomy. A telescope placed here. Can monitor deep space. Without eclipse from earth or moon. without eclipse from Earth or Moon and can send data back to Earth. Can send data back to Earth. Data back to Earth. Write down the next point. L3 point is not very suitable. L3 point is not very suitable. Is not very suitable, as it always remains behind. As it always remains behind. Always remains behind Sun. Always remains behind Sun. But what about L4 and L5 point? Turns out that L4 and L5 point, as of now, we are not using them. Maybe in future they will have a lot of utility. L4 and L5 are perpendicular to this straight line L1, L2, L3, perpendicular to this plane. And L4 and L5 points are what we call stable points. In physics, when we use the word stable point and unstable point, and there is another point called semi-stable point, it has a very specific meaning, but I can explain that with a simple example. Imagine a spherical ball, a katori, imagine kar lo, and I put something here at the bottom of this ball, and if I displace it a little bit, it is going to come back to its same position. So this point is an example of equilibrium. But this equilibrium is stable equilibrium, because even if I displace it a little bit, it will try to come back to its equilibrium point. So this is called stable equilibrium. And by the way, this will happen in all directions. So this is a three-dimensional ball. So even in this direction or this direction, nowhere in which direction I displace, it is going to come back to the same point. Now you reverse this ball and put something here at the top. And yes, there will be a point where it is going to be stable. It will be in equilibrium. But the moment I displace it even a little bit in any of the direction, it is going to fall down. So this is also an equilibrium, but this is called unstable equilibrium. Now there is also another point. And to imagine that, you will have to imagine a horse saddle. That is called semi-stable point. So this point here is stable point. This point here is unstable point. Have you seen a horse saddle? घोड़े पे बैठने से पहले जो saddle होगा. Imagine that saddle shape. I am going to show you the picture also. But imagine the saddle shape, that it is lifted from the front and lifted from the back. But then from the side where you put your legs, it has to be declined shape. The reason is very simple, so that you can put your legs properly. But meanwhile, if horse suddenly stops or accelerates, you do not go back or forward. Hence the top part and back part is lifted. So think of where you are sitting. That is a point of semi-stability. That if you go back or front, you come back to the same point. But if you fall sideways, you fall down. So this is a point where in two directions you are stable, but in other directions you are not stable. So such points are called semi-stable point, and in fact it is named after that saddle. In mathematics, this point is called saddle point. It will look something like this. Talking about something like this, that you have a saddle point that in two directions. Don't worry, ये सब चीजें आपको बिल्कुल याद नहीं रखना है. Why I am only explaining this? Because Lagrangian points were in news a lot, and we should know more information about even L4, L5, which has nothing to do with Aditya mission per se. Now L4 and L5 points जो हैं, they are proper stable points. That the very first example I gave you, that spherical ball. What it means is that if something is at L4 and L5 point, then it will remain at L4 and L5 point, even if because of some other factor it gets displaced a little bit, doesn't matter. It will come back to around the similar points it has existed. But the same is not true in case of L1, L2 and L3 point. L1, L2, L3, these are semi-stable points. That in few directions they are stable, but in few directions they are not very stable. And that is why, be it Aditya L1 mission or be it James Webb Space Telescope, they will carry some amount of fuel and there will be little bit of thrusters part of these missions, that just in case if they start their motion towards sun, we need to bring them back. Or if they start their motion again in the opposite direction, we need to push them back. So we need to ensure that they are in the same orbit. Yes, they are stable in few directions, but they are also unstable in few directions. And because of some unknown factor, whatever that factor can be, if they start their motion in those unstable direction, then we should have this capability to bring them back. So Aditya L1 mission ho, chahe Webb telescope ho, they do carry some fuel, they do have their own motor, they do use very small thrust. The amount of thrust which is required to place them back is very less, but nonetheless we have to do that. Otherwise, after a point of time, we will not be able to bring them back to the original point. So Aditya L1 mission or Webb telescope, they are at these points which we can call semi-stable point, that saddle point. But something at L4 and L5 point, if we get to launch something at L4 and L5 point, then they will be in a perfect equilibrium. As of now, they do not have a lot of utility. We haven't sent something at L4 and L5 point, but it is quite popular in science fiction novels. A lot of science fiction novels, L4 point has been explored, that maybe humanity will bring a very large space station there. A space station, a self-functioning space station, which can revolve around sun without consuming a single drop of fuel. And it will be in a stable point because it is L4 or L5. And it can inhabit, let's say, thousands of people. So something like that. Again, maybe a few thousand years away from now, if we survive, then we can perhaps have a very large space station there. And L4 and L5 ka jo impact hai, we already know it happens even within solar system. Jaise, you might have read about asteroid belt. Padha aapne? Where does asteroid belt exist? Between Mars and Jupiter. Like you have this very huge space between Mars and Jupiter, and lakhs of asteroids are revolving around sun. But if you know then in detail, then you also know that there is another group of asteroid. Now we have read about this belt of asteroid between Mars and Jupiter. Like there are millions of asteroids, very small asteroids, which are perhaps when the solar system was formed, all of those things which did not find any planet or any star, did not become part of star, those fragments are left and they became asteroids. So most of the asteroids are between Mars and Jupiter. But if you look closely, you'll find that, look at this 2 shape here. So don't look at this part, but only this group of asteroid. That you have 2 group of asteroids, one group of asteroid which is preceding Jupiter, and another group of asteroid which is preceding Jupiter. These asteroids are called Trojan asteroids. Now why they are called Trojan asteroid, that comes from Greek mythology, that you have this entire story of Trojan horse, that you allowed it to enter inside the city. So this asteroid was roaming here and there, but it got stuck into that L4 and L5 of Sun, Jupiter, Lagrange point 4 and 5. So this is at the Sun, Jupiter ka jo L4 and L5 point hai. Now it is stuck there. So this is revolving around Sun, but that stability for that revolution around Sun is not only because of Sun, it is also because of Jupiter. So this group of asteroids called Trojan asteroids, they are stuck around Jupiter. And by the way, by doing that, Jupiter in a way saves planet Earth. A lot of these asteroids would have come towards Earth also, but Jupiter allows them to fall into its own gravitational pit, and many of those asteroids will simply not come towards Earth. Yes, even despite that, some asteroids can come. In past, it has happened. I hope everybody has read about the extinction of dinosaurs that occurred because of an asteroid impact. But if Jupiter was not there, many more asteroids would have come towards Earth. So, and by the way, ये जो Trojan asteroids हैं, अब ये जो group of asteroids हैं, they are only and only because of Sun's gravitational pull. But these 2 group of asteroids are because of both Sun and Jupiter. So even within solar system, we see the impact of Lagrangian point, that L4 and L5 point. Lagrange had no idea when he was doing all of this calculation that it will find so much of utility in the field of astronomy. He was just interested in solving a mathematical problem. But we use that mathematical problem to launch all sort of probe, and we also can explain lot of astronomical phenomena which was not explainable before. तो आप लिख सकते हो in next bullet point, L4 and L5 points, L4 and L5 points are stable points, which means objects can potentially orbit around them. Objects can potentially orbit around them. And they will tend to stay put. They will tend to stay put. They will tend to stay put relative to the main bodies. Relative to the main bodies. They will tend to stay put relative to the main bodies. Compared to this, L1, L2 and L3 are semi-stable points. L1, L2 and L3 are semi-stable points. L1, L2 and L3 are semi-stable points. Any questions from Aditya L1 mission, from whatever we discussed in the last class? And in today's class, the concept of Lagrangian point. If you have any questions, you can go ahead and ask. Yes. Polar sun synchronous orbit will give this oblique point of view. And we want a direct point of view, particularly with respect to things like solar. The question is that why not polar sun synchronous orbit? Why not line of illumination at polar sun synchronous orbit? That will be the second best situation. The second best place where we can do all of that will be polar sun synchronous orbit. But this will give you an oblique point of view, and we want a direct, it's like you are watching a movie and you want the front seat, the best seat which is available to you. So think of like this, that yes, you can watch a movie also from that aisle seat on the top of the second floor, that you get to see those things all the time, but I want a better view, I want a front view, and that is why L1 point. So, which essentially means that the type of data you get to gather around at L1 point will be much better compared to what you can do at polar sun synchronous orbit. Any other question if you have? So let's discuss a simpler topic, Gaganyaan mission. Give this heading, Gaganyaan mission. I do expect a question from this topic this year's examination itself, either in prelims or mains. Jaise you can practice a question here about Aditya L1 mission. Write down a question. What are the scientific objectives of Aditya L1 mission? What are the scientific objectives of Aditya L1 mission? What are the scientific objectives of Aditya L1 mission? The first dedicated solar observatory of ISRO. What are the scientific objectives of Aditya L1 mission? The first dedicated solar observatory of ISRO. First dedicated solar observatory of ISRO. Why was it important? Why was it important to send this mission 1.5 million kilometers away? Why was it important to send this mission 1.5 million kilometers away? 1.5 million kilometers away from Earth. From Earth. That's it. Two parts of the question, 15 marks, 250 words. This can be a practice question. Try to solve this, try to write this answer at your home. And you already know all of the points, but you just have to summarize all of that very quickly. So in this question, jaise, do not have to write at all about L2, L3, L4, L5. Just focus on the utility of L1 point and talk about the scientific objective of Aditya L1 mission. It has all of these scientific payloads, 7 scientific payloads. All of those 7 scientific payloads have their own utility. And sending this mission was very difficult. It took, in fact, about 4 months. That we used PSLV here. So we used PSLV rocket to send this first into an earthbound orbit. And we kept raising that orbit. And then once it is sufficiently far away, we gave it a boost where it started its motion towards L1 point. And it took 4 months before we can find, or we can give the final thrust to the motion that it can find a stable orbit around L1 point. So Aditya mission ko complete hone mein, like from the time we launched and from the time it reached to L1 point, it took 4 months here. And that is why I said that this is not less of a success compared to Chandrayaan 3. Anyways, give the heading Gaganyaan mission. L4, L5 ka bhi same problem hai. Why not L4 and L5 point? L4 and the question was that why not L4 and L5 point for solar observation? We want a better view of solar flares and coronal mass ejections. That between Earth system, we can actually, all the scientific objectives which we do have, that we want to study solar wind or CME or solar flare, L1 point is the most suitable point, considering the fact that I can also send that data back to Earth all the time. So hence L1 point, not L4 or L5 point. Give the next heading Gaganyaan mission. I only want to discuss 2 things here. But first, let me tell you some of the factual details of this mission. The details are very simple, very straightforward. That group of 2 or 3 astronauts, the total selection is 4. I hope everybody has read the news. That now we know who are the 4 astronauts. But out of those 4 astronauts, a group of 2 or 3 will spend about 2 to 3 or maximum 4 days in low Earth orbit of about 400 to 500 kilometer. And then they will come back on Earth. Simple, straightforward mission. ISRO is venturing into manned mission for the first time. Before ISRO, 3 other agencies which have successfully done it. Russia was the first, US became the second country, and China became the third country to successfully achieve manned mission. And if Gaganyaan becomes successful, then ISRO will become the 4th agency to successfully do that. ISRO is taking all of the measures so that this mission, everything goes safely. And even before Gaganyaan mission, there will be 2 missions. One mission will be an unmanned mission, nothing on the place. But the goal will be that it is going to be ejected with the help of LVM-3, and we will try to return it back and we will recover it on the Earth. In the second mission, we are going to have a robot, an AI robot in fact, and we have given it a name also. We have given this robot a name also, Vyom-Mitra. And Vyom-Mitra, Vyom means sky, basically, Akash. So Vyom-Mitra is an AI robot who will go as part of the second mission. And then the goal here will be again same, that Vyom-Mitra will revolve around Earth and we will have to recover it back on the Earth. When these 2 missions are successful, then we will send a group of 2 or 3 astronauts for 3 to 4 days into LEO of 500 to 600 kilometers. So these are the factual details of the mission. ISRO is spending about 10,000 crore rupees on this mission. One of the most expensive mission ISRO has ventured into. So I have 2 questions here, only 2 questions. The first question, and I want a discussion about this, rather than me telling you, I want a discussion about these 2 questions. The first question I have is that we do know that manned missions are a lot challenging compared to unmanned missions. But I want you to tell me that what are the specific challenges in successive stages which we are going to face? That what type of challenges? And try to be more specific. Do not say that safety or security. What type of safety, what type of security? That is the first question. And the second question I have for you is that why this mission? Like, why are we spending 10,000 crore rupees on a manned mission? We know the benefits of unmanned mission. We know that what a communication satellite does, what a remote sensing satellite does, and how it contributes to economic growth and overall development of our nation. What benefits do we think will come from Gaganyaan mission? Like what benefits will come from this manned mission, right? And by the way, remember that this will be a question asked by many foreign newspapers. BBC में एक question आएगा that India जहाँ पे इतने सारे लोग गरीब हैं वो लोगों को आकाश में भेज रहा है. So some editorial will be there. So rather than looking at the intent, whatever, but look at the argument itself, and is this a strong argument? And can we counter this argument with something else? So that is my second question, that why this mission? So let's start with the first question first, only first question right now, that what type of specific challenges will come in Gaganyaan mission? I want your inputs here. Okay, so one point, that safety in the context of space radiation. जो अर्थ का एटमॉस्फेयर है, that filters lot of cosmic radiation, but once you are outside Earth's atmosphere, that filtration is not there, so you're exposed to more radiation. That's a very valid point. Yes, somebody? Hanji. Okay, now that's also a very good point. One of the biggest challenge, in fact, will be after spending those 3-4 days and then coming back to Earth, because as long as you are in space, you're not facing any air drag, air friction. But the moment you enter into space, there is a huge air friction, and that air friction is going to generate a lot of heat energy, which will increase the temperature. So the object in which you are traveling and entering inside Earth, that temperature is going to rise up to few hundred or maybe even 1000 degrees Celsius. You are adequately shielded from that increase in temperature, and overall it does not lead to any type of accident. That will be one of the biggest challenge which we are going to face, and you are absolutely right there. You have read about Columbia mission, Kalpana Chawla ka jo pura accident tha. So that accident happened when the mission was returning back from space. So yes, that will be one of the most serious challenges we are going to come across. What else? Perfect. That's also a very good point, that we are sending people, but people require certain basic requirements to survive, no matter how difficult or how simple conditions are. So to create a habitat within space so that you have adequate supply of food, water, you also have ventilation system, that carbon dioxide has not accumulated a lot, you have enough supply of oxygen there, right? You need to invest into recycling system. All of that thing, you need proper space suit so that you are protected from the dangerous radiation. All of that thing is required so that there is a habitable condition within space. What else? Real-time information. Okay, okay, that's also a good point. ISRO, in fact, ISRO has developed a very good app for it. So knowing the real-time information about astronauts themselves, that what is happening each and every second, what is happening inside that space capsule which they are traveling into, which they are orbiting into. So knowing all the time what is happening, that will also be a challenge. Yes. What else? Training, because India does not have any experience in manned mission. In fact, we are relying a lot upon Russia here, experience again by Russia. So we have a lot of support from Russia and France here, and that's also a very good point, that training people so that they can survive in such tough condition is also a challenge. Yes. Sorry? Training conditions for such a tough environment. Earth-like environment. Okay, that exactly. We have established that we have to create as much close as it is possible to Earth-like habitat. Of course, we cannot achieve everything, goes without saying, but survival के लिए जो जरूरी है, इतना हमको we have to invest into it. What type of sophisticated equipment? But हमारे पास इतना powerful launch vehicle है that हम गगनयान mission भेज सकते हैं. So but none, you are right that we need, जैसे we are going to use LVM-3 for that, and LVM-3 का अभी जो ये payload होगा, जो top payload होगा, it will contain this capsule, and this capsule can be further divided into two parts. The first part where astronauts are going to live, we can call it crew module, and all of the important instruments so that this crew module can survive. For that you have this service module, and that service module also has enough fuel for the return journey, because remember, you're orbiting around Earth and you have to come back. For that you need fuel. So you have enough fuel for the return journey. So once it re-enters into atmosphere, it is going, that will be fueled by that service module, and it is going to be separated, by the way. So only the top part is going to enter finally inside Earth, and it has to fall somewhere in Indian Ocean, where we need a team of doctors and people who can rescue the astronauts immediately. They will have to be sent to hospital for their overall bodily checkup. So all of that, and by the way, one group of challenge will be even during launch itself, that LVM ke jo 3 stages hain, they have to function exactly well. That first stage separation, second stage, third stage. That has to, and a lot of jerk happens, by the way. So you have to be you are stuck to your seat and you are facing a lot of jerk, and then you go into space. It requires a lot of physical strength, but also a lot of mental fortitude to survive in such tough condition. So there will be multiple sets of challenges in successfully conducting this manned Gaganyaan mission, right? And ISRO will become the 4th agency to do that. The second question I had is that what type of benefits do we think will come from this mission? Like, why are we sending this mission? Why are we spending 10,000 crore rupees on a manned mission? Such as? Never use the word big brother in answer writing. So that is one of the accusation against India. Don't use the word big brother. Like it's actually, so I know about Gujarat doctrine, but it's one of the things which our neighbors do not like. That big brother kab bully ban jaye. We do not want that to happen. But your point, I totally take that point, that India projects its space capability as a soft power, particularly to the global south. Global south means developing nations. So the capability of India, that we can have sophisticated missions at such cost effectiveness, that enhances prestige, that increases our soft power. Soft power will be taught in detail in higher classes. Ek to hard power hota hai, which is your military capability. Soft power is your culture, Bollywood, yoga, cuisine, clothing, all of that is part of your soft power, including space. So India does project its space capability as a soft power, and that will definitely be a geopolitical advantage. But let's come to more concrete points, like more points which can be quantified. That is one of the benefits, qualitative benefit or intangible benefit. I want to talk about more tangible benefit, that what type of benefit will come from Gaganyaan mission. Effective in? And what type of benefit will occur because of that? Precise information about what exactly? So when you use the word effective and precise information with the help of sensors, what type of information you are talking about? Be very clear in your thought. Do not make up words without any meaning, but it's totally fine. So I do think, I will add a point here. One of the very important thing we can do is that we can look at the vitals of the people who are into such tough condition. And by the way, that has played a very important role in past, that how astronauts' body react to or function to such adverse conditions. So that allows us to understand more about human body, which has applications in medical sciences. So yes, that can be a point we can mention. What else can we mention? Okay, now that's a good point. In fact, यहाँ पे हमारा बहुत ज़्यादा goal experiments पे अभी तो कम है. But one of the point which I was hoping that somebody will point it out, or maybe some online students, they have done it, is that ISRO is planning to have our own space station. पढ़ा होगा आपने, भारतीय अंतरिक्ष स्टेशन की बात चल रही है अभी. That by 2035 we want to start working on our own space station. अभी जो space station है, the most famous space station is International Space Station. Now, International Space Station is a collaboration among many agencies. You have US, you have Russia, US, Russia working together on International Space Station. You have Japan, Canada, Europe, 5 agencies. India is not a part of it. India is not part of that space station. So space station is like a platform where you go, you stay for days, for weeks, for months. Few astronauts have lived for more than 400 days also, so more than a year also, and then they have come back. And yes, you are absolutely right that they get to conduct a lot of experiments there. Experiments regarding, can we grow plants in artificial condition, in artificial light? How bacteria will behave, microbes will behave in such condition. how different animals will behave. So there are so many different type of experiments on material sciences, on biomedical sciences, on living organism. It's mind-boggling, and that has actually played a very important role in understanding about a lot of things. So गगनयान का तो चलो as such कोई purpose नहीं है that we go and जो भी experiments हम करेंगे वो बहुत ही minimal होंगे. But Gaganyaan will be a stepping stone that once you do have a manned space mission, then India will also have its own space station in the future. And yes, that space station will help us a lot in so many different type of experiments. There is another space station which you should know about. China has completed its own space station. We call that Tiangong. So China has named it Tiangong. And if India does that, India will be the third agency to achieve that. Any other question? Oh, sorry, any other point if you want to add? Okay, that's a good point. Private sector investment. Lot of work is happening with the help of private sector. In fact, in general, you should know that as of now, Government of India has allowed private sector participation in space activities. और ये बहुत recent development है, 2020 का development है. Before 2020, almost everything in space sector was done by ISRO. ISRO works under Department of Space. Department of Space directly works under Prime Minister. Does not work under any ministry. Department of Space directly works under Prime Minister. And everything, making rocket, launching it, launching satellite, collecting data, almost everything was done by ISRO. In 2020, Government of India announced that we are going to allow private sector participation, even in rocket making, launching, and few important success already has occurred. Jaise, Skyroot, that's a very good example. Skyroot is a very good startup which launched a rocket last year, and it only reached to 50 kilometers, but nonetheless, that in itself is a big achievement. And another startup perhaps you should know is, this startup is called Agnikul Cosmos. Sorry, there is a startup called Agnikul Cosmos. And Agnikul Cosmos is working on a rocket, and I give kudos to their name. It is called Agniban. So the name of their rocket is Agniban, and they plan to launch it. In fact, they were planning to launch it last week, but this has been delayed. And they are actually developing a semi-cryogenic engine, which even ISRO has not done it. So private sector participation in general has been allowed, and you are absolutely right that even in Gaganyaan there will be more and more private sector participation. Okay, that is also a very concrete point which I was hoping that somebody will point out. That think of space tourism as a new emerging sector. That you have an entirely new economic sector which is called space tourism, where people get to space, even not astronauts, even common people, sorry, not common people, ultra rich people, but you go to space and you come back. So space tourism is an entirely new economic sector, and you already have few companies there. You have companies like SpaceX or Blue Origin, जो जेफ बेजोस की कंपनी है, जो अमेजोन के CEO रहे थे अभी, or even Virgin Galactic, which is a company of Virgin Airlines. So you have many companies which already have shown their capability, and they already are sending astronauts into space. And even ISRO has made it clear that by end of this decade, ISRO wants to emerge as one of the player in space tourism. So think about that. If ISRO will enter, it will do that at very low cost, and space tourism में जो ISRO का contribution है, that is going to increase. Overall, global space economy में जो India का contribution है, that is going to increase. So we can write many concrete benefits, but also intangible benefits like geopolitical benefits, or the fact that how it can inspire younger generation to pursue STEM courses, science, technology, engineering, medicine. So write down few things here. We can, yeah. So all such missions invite more and more global collaboration. That will be a point we definitely can mention. But we are not using PSLV first of all, because PSLV ka jo capacity hai, that is only 1700 kg. So GSLV does have lot of capacity, and it has capacity of 8000 kg in LEO. And yes, for a manned mission, you need to carry lot of things. You need to carry devices, food, water, oxygen, recycling system. By the way, that is also something you should know about, that how recycling system plays a very important role in space technology. That lot of times astronauts use their own urine also. That own urine is filtered out so that water consumption or water availability does not decrease. And one more point which I would want to add in this benefit of Gaganyaan mission is that lot of research and a lot of products which we use in our day-to-day life, they were actually result of space research. So the point is that research and development in one area, the applications are not limited to that area only. There are many spin-off benefits, and we should talk about those spin-off benefits. Just I will give you a few examples. The very example I told you, that this urine purification, the same technology is now used in wastewater treatment, that we can treat wastewater and we can improve our supply of water. जो water recycle की हम बात करते हैं, that has improved because of space research. Or you might have read about laser surgery or robotic surgery. Both laser surgery and robotic surgery, they are result of space research. There are many materials which we use, thermally resistant materials, materials which are soft but still their temperature of burning is very high, and they were actually explored for rockets, but now we are using it even in day-to-day life, things like metros and buses or even household products. Or think about how astronauts have to carry food, but that food ka jo shelf life hai, that should be longer so that it is consumable and nutrition should not decrease. So those techniques now find applications in food processing sector, how to increase the shelf life of food without compromising upon the nutritional value. So development, sorry, we can talk about that also, that this artificial growth of plant, how it can contribute to hydroponics. So the point is that research and development in one area contributes to applications in many areas, not just limited to that area. And those benefits are called spin-off benefits. So even Gaganyaan can have lot of spin-off benefits. So write down few things here about Gaganyaan mission. It will be the first dedicated manned mission. It will be the first dedicated manned mission of ISRO. A successful Gaganyaan mission. A successful Gaganyaan mission. Gaganyaan mission will make ISRO the fourth agency. Will make ISRO the fourth agency. Will make India the fourth country. ISRO ये हटा देना. Will make India the fourth country after Russia, US and China. After Russia, US and China, to achieve this capability. To achieve this capability. ISRO plans to send 2 to 3 astronauts. ISRO plans to send 2 to 3 astronauts for 3 to 4 days in LEO. 2 to 3 days in LEO, low Earth orbit, LEO, low Earth orbit, before crewed mission, crude means manned mission, an unmanned mission, and a mission carrying an AI robot, Vyom Mitra will be sent. AI robot Vyom Mitra will be sent. So the factual details है. Give the heading challenges associated with manned mission. Challenges associated with manned mission. Write down in bullet points. A A constant supply of oxygen and food. A constant supply of oxygen and food. Oxygen and food. Waste management. Waste management. Maintaining appropriate temperature and pressure. Maintaining appropriate temperature and pressure. Will be crucial life support systems. Will be crucial life support systems. Write down the next point. Will be crucial life support systems. Crucial life support system. Write down the next point. Astronauts will be exposed to higher levels of radiation. Astronauts will be exposed to higher levels of radiation. Higher levels of radiation. Third point. Extended exposure to microgravity. Extended exposure to microgravity. Microgravity का मतलब यहाँ पे gravitational force is very less. Microgravity can have adverse effects on muscle, bones. Extended exposure to microgravity can have adverse effects on muscles, bones. Next, being in a confined space. Being in a confined space. Being in a confined state, isolated from civilization. Isolated from civilization. Poses psychological challenges. Isolated from civilization poses psychological challenges. That mental fortitude which I was talking about. Psychological challenges. Re-entering Earth's atmosphere. Re-entering Earth's atmosphere. Earth's atmosphere is challenging due to heat and forces experienced by spacecraft. Is challenging due to heat and forces experienced by spacecraft. Spacecraft. And one last point you can add. The crew module must be swiftly located. The crew module must be swiftly located. Swiftly located. And astronauts must be safely retrieved. Astronauts must be safely retrieved. Give the next heading. Benefits of Gaganyaan mission. Benefits of Gaganyaan mission. Write down in bullet points. Successful manned mission will be stepping stones towards. Successful manned mission will be a stepping stone towards Bharatiya Antariksh Station. Stepping stone towards Bharatiya Antariksh Station. जो अभी इंटरनेशनल स्पेस स्टेशन है, that is a collaboration among many agencies, but ISRO is not one of them. Bharatiya Antariksh Station Next, ISRO will emerge as a player in space tourism. ISRO will emerge as a player, as a key player. ISRO will emerge as a key player in space tourism. Next point, investing in advanced technologies. Investing in advanced technologies have many spin-off benefits, spin-off benefits that trickle down to other sectors, You can write down few examples. For example, many techniques in food processing, water purification, laser and robotic surgery, thermal resistant materials, a result of space research, In fact, the best example I can give you is MRI scan. I hope everybody knows about MRI scan. MRI scan is a very powerful tool available for doctors that without invasion, without any type of surgery, invasive procedure, it allows doctors to know about internals of your organ, including your brain also, for example. So it's one of the most powerful tool available to modern medical science, where we know the internals of our organ without any type of invasion, any type of surgery. And you'll be surprised that MRI scan ka jo origin hai, that goes back to astronomy. That a scientist who had no interest in biology whatsoever, no interest in medical science, he wanted to know about the radio signals which come from distant stars and galaxies. And then he found this technique called nuclear magnetic resonance. I'm not going to explain that. But there is a technique called nuclear magnetic resonance. And then he realized that how these radio waves can be analyzed with the help of nuclear magnetic resonance. And that nuclear magnetic resonance is the science behind this technology, MRI scan, magnetic resonance imaging. So that is a result of development in astronomy. So research and knowledge enhancement in one area has applications in so many different areas. And that is why this entire debate that either Gaganyaan or social sector is a flawed debate. This line of argumentation is bad. And there will be people who will make this argumentation that why to spend 10,000 crore rupees when so many people are living below poverty line, right? So we can do both. We can prioritize both. And by the way, if we do talk about फालतू का expenditure by government of India, then उसका एक बहुत बड़ा list है. Space is not one of them. Space research is not one of the expenditure, which we can say that this expenditure is, why are we spending this much money in a particular area? You can write down few more points. The space industry can bring economic returns. The space industry can bring economic returns. And private sector participation in space will further help in it. Private sector participation in space will further help in it. Few more points you can add. Establishing a presence in space has geopolitical advantages. Establishing A presence in space has geopolitical advantages. Geopolitical advantages. It allows a country to have a say in future space treaties and agreements. Have a say in future space treaties and agreements. And one more point you can add, one last point. Space missions open doors for international collaborations. Space missions open doors for international collaborations. International collaborations, which leads to shared knowledge, resources, and mutual benefits. Which leads to shared knowledge, resources, and mutual benefits. Shared knowledge, resources, and mutual benefits. The best example I can use for this is this thing of collaboration between US and Russia in International Space Station. That US, Russia, they are adversaries on ground, without a doubt. They're fighting, like they have fought so many wars, indirect wars, not directly in past. But even today, you have, for example, let's say Ukraine. That Ukraine had so much of support from US and other NATO countries. But at the same time, there was one point, there was a chance that International Space Station mein jo pura collaboration hai, this will going to come to an end because of this Ukraine war. But somehow still countries agreed that we should keep on collaborating. And US, Russia, for example, have this very interesting mechanism where US uses its own rocket to send Russian astronauts, and then Russia uses its own rocket to send American astronauts. So such type of collaboration that can occur in space research, and doing away with the petty fights which we have on Earth. So this is also one of the benefits which can be talked about, that how it will allow collaboration with many other countries, even for India. I do expect a question in mains examination on this topic this year, although 2025 में launch होगा, तो उस time तो और ज़्यादा important होगा आपके exam के लिए. But I also expect a question in essay. This is a topic which you should prepare for 125 marks. That Gaganyaan mission, इसके benefits क्या हैं, challenges क्या हैं, why to invest into Gaganyaan mission, things like that. So this is one of the topic from science and technology. If I have to say that, okay, one topic which you should also prepare from the essay perspective, this will be one of the topic. I will take a break here. After that, we will try to complete remaining topics as soon as possible, because I do want to start nuclear technology in today's class. Give this heading, ExpoSat. There's a question, what are things that cannot be experimented by robots in space? The very fact that we cannot know how human body will be affected by space radiation or away from gravity, that cannot be done by robots. There are many type of experiments now which can be done by AI robots, and they are actually playing some very important role. For example, think about all of the Martian missions of NASA. Essentially, all of them contain robots. That these are robots which are conducting experiments, and then they are telling us about Martian surface. But wherever we can reach, we try to do that with the help of human beings itself. There is a question that while answering questions, for example, write about remote sensing satellite, mention applications of IRNSS. Are you talking about the same questions? Remote sensing, IRNSS is not a remote sensing satellite, it's a navigational satellite. Should we mention only the limited aspects given on official website? Can we mention all the applications? You can mention all the applications. So rather than trying to mug up what is given on the website, try to understand what is remote sensing, and then try to think about in what areas it can be utilized. Specific applications, use that as an example. Just say you came across, let's say, forest monitoring, but you also know of a very specific example where we have done that with the help of remote sensing satellite. So whatever specific examples you have, use them as example, not as your primary point. So mugging up will help you a lot, but ideally that should be to complement your existing knowledge, that you are developing an aptitude, you are understanding a topic, And then you are trying to further enhance this knowledge by trying to remember relevant information, relevant facts from newspaper, or in this case, what is available on ISRO's website, right? So it will be helpful, but that should not be like that is the only thing you have to do. XPOSAT का जो full form है, that is X-ray polarimetry satellite. This was not given as much coverage as Aditya L1 mission, but because it is a mission of ISRO, we should know the details of it. I do think for this year's examination, this is an important topic, maybe even for next year's examination, because this will remain now in space and it will send us data for next 5-10 years also. So there are two words here, X-ray and polarimeter. In the previous class, I told you that how light speaks to us, how light provides us information, various types of information. And I also asked you that ponder about this, that how all of the light, whatever we gather, it is a carrier of information. Our eyes are limited, that they can only see visible light. But objects can emit light of various frequencies. They can emit light of radio wave also, that is also there. They can emit infrared also, they can emit ultraviolet also, or they can emit X-ray also. So X-ray, the same X-ray which you might have undergone through in some medical procedure for diagnosis, like abhi haddi toot gaya. But same X-ray, turns out that there are natural sources of X-ray in the universe. In the last class itself, I told you that solar flare in itself is a great source of X-ray. That solar flare is X-ray, UV, visible, infrared also, but X-ray is a major component of it. But apart from sun, there are many other sources of X-ray in the sky. The goal of XPOSAT is to know about those sources and what those sources are and what are their properties. So X-ray is emitted by many other sources. Now what are those sources? Those sources can be a binary star system, two stars orbiting around each other. That source can be supernova. I will be talking about supernova in later classes. Supernova is when a very heavy star undergoes a collapse and this leads to a violent explosion, an event which is so bright that for a brief duration it can outshine an entire galaxy. So think of a supernova happening in one part of Milky Way galaxy, and by the way, Milky Way has about 400 to 500 billion stars. So I'm talking about an event which can outshine the entire Milky Way galaxy, even though it will only be for a moment. It happens when very heavy stars undergo supernova explosion. That will be a source of X-ray. It happens when a black hole feeds upon the nearby material. At the center of every galaxy, you have a black hole, which we call supermassive black hole. And a supermassive black hole can be inactive, that it is not feeding upon the nearby substances. But an active supermassive black hole starts feeding upon all the nearby material, including stars, by the way. But before it can feed upon them, before it completely engulfs, let's say, a huge star, those stars will accelerate towards black hole. And as they accelerate, their energy will increase and they will radiate more and more light. So this entire setup, that at the center, there is a supermassive black hole, and then you have all of the particles around this black hole, and they are getting more and more energy as they are coming closer and closer to black hole. This entire setup is called quasar. And quasar is a great source of X-ray. Neutron stars are a great source of X-ray. I'll be talking about all of those things in later classes when we will discuss about Dr. Chandrasekhar, Dr. Subramaniam Chandrasekhar. But the purpose of XPOSAT here is, so this is now second astronomical observatory. So AstroSat, that was launched in 2015, and XPOSAT, this has been launched just this year, in fact, in the month of January. And XPOSAT, iska lekin bahut specific purpose hai, to know about X-ray sources in the sky. To distinguish between these X-ray sources, it uses two payloads, and both of these payloads are a type of polarimeter. So thermometer measures temperature, barometer measures pressure, polarimeter measures polarization. There is a property of light which is called polarization. I'll be talking about this property, but not in today's class. In the next to next module, जब हम ICT पढ़ेंगे, light के बारे में अभी हम और पढ़ेंगे. We haven't completed our discussion about the nature of light, that what exactly light is. I'll be talking a lot about the nature of light and how it plays a very important role in so many different type of technological developments. So light has this very inherent property called polarization, and the purpose of this satellite then will be to measure the polarization of X-ray, and based on that polarization try to distinguish between the sources, that this is X-ray of, let's say, a neutron star, or this is X-ray of supernova explosion, or even a quasar. So this is not a talked mission, but I do think this is an important topic for UPSC. आप लिख सकते हो, write down few things here. Recently ISRO launched ExpoSat. ISRO launched ExpoSat. ExpoSat. A mission to study cosmic sources of X-rays. A mission to study cosmic sources of X-ray. Specifically focusing upon the polarization, of X-ray emitted by these sources. Polarization of X-rays emitted by these sources. Polarization emitted by these sources. Polarization of X-rays emitted by these sources. X-ray sources can be, write down, X-ray sources can be binary star systems, supernova, quasar, among others. So small topic, but nonetheless an important one for UPSC. Give the next heading, space debris. इसरो के और भी प्लान्स हैं. ISRO is planning to launch Shukryan in future. Shukryan will be launched perhaps somewhere in 2030s, so 2032, 2033 perhaps, a mission to Venus. But this will only be an orbiter mission. Venus is one of the most difficult planet to explore. Venus has a very dense atmosphere and it has a very toxic atmosphere. In fact, it is so toxic that literally sulfuric acid falls on the ground. So it rains acid on Venus. A planet which rotates from east to west. Very interesting planet. Called Earth's twin sister. The reason it is called Earth's twin sister because of the similarity in mass and composition and similarity in origin also. So hence twin sister word. But apart from that, apart from the similarity in mass, so it has almost about like 0.95 times mass of Earth. So very similar, little bit less than Earth, but very similar to Earth. It has acceleration due to gravity about 9.5 meter per second square, very close to 9.8 meter per second square. But its atmosphere is very different. It's in fact, it is the hottest planet. Or it is also the coldest. So average temperature on Venus is much, much more. Average temperature on Mercury is less. Mercury is closest to Sun, but Mercury does not have an atmosphere. And because of that, when Mercury receives sunlight, it heats up to a few hundred degrees Celsius. But because it does not have atmosphere which can trap the heat, so during night, whatever part of Mercury is during night, the temperature goes to even less than minus 100 degrees Celsius. But on Venus, that does not happen. So Venus, on an average, is a hotter planet compared to Mercury because it does have a very thick atmosphere. However, that atmosphere is not very suitable for life. Nonetheless, ISRO does plan to send a mission. And by the way, this will not be the first mission. There have been missions of other space agencies, but this will be the first mission of ISRO to explore Venus. Only an orbiter mission, but it will be launched somewhere in 2030s. We do not have to know about it right now. ISRO is also planning that somewhere again in 2030s, we will send MOM2. जो मार्स ऑर्बिटर मिशन है उसी का हम सेकेंड वर्जन एक और हम मार्शियन मिशन हम लॉन्च करेंगे. ISRO is planning Chandrayaan 4 also, and Chandrayaan 4 and finally ISRO का जो एक और गोल ये है that by 2040 we aim to send astronauts on the surface of moon. And ISRO is also planning to have its own space station, which I talked about earlier. So these are some of the future missions in pipeline. Timeline will become much more clear as we go ahead. So keep updating this information. Whatever we have discussed in the class, my hope here is that it will now help you in better understanding of topics from space technology. But nonetheless, it will not be enough. You'll have to update this information from current affairs. So take newspaper reading very seriously, which I discussed in the very first class. One of the last topic I can discuss here about space is this issue of space debris. That human beings have been sending missions to space for more than 50 years now. And many of those missions, so for few things have happened. For example, rockets के जो upper stages हैं, rocket separates the satellite. The final separation occurs at very high altitude, somewhere around 200-300 kilometers. But during that separation, during fairing, some parts of the rocket can stuck in the Earth's orbit itself. That is one of the most major source. So this is like a kachada. It's literally an unnecessary object which is revolving around Earth with very high speed. And another source will be that in past rockets have exploded, particularly when the upper stages explode. That will also lead to very smaller pieces, fragments into space. In past, few satellites have collided. It's a very rare phenomena, but some accidents have occurred in the past, although they can be counted on finger. So that is quite rare. But whenever that happens, that is also an accident, and that accident will produce lot of fragments. What happens to satellites when they are not functional anymore? That they have fulfilled their purpose and they are not doing anything. Three things can happen. You can leave them as they are, but that's not good because in a way they are also debris. If they are not doing anything but revolving around Earth, then they are also a type of debris. So ideally, two other things can happen. That if they are already into some high orbit, let's say they are in geostationary orbit, then you can give them more boost and you can place them into an orbit of, let's say 40,000, 45,000 kilometers. These orbits are called graveyard orbits. Like literally these are graveyards of satellites that once they have fulfilled their purpose, you place them into a higher orbit. They are not bothering any other object into any of the orbit. But yes, they will still be revolving around Earth, but they are not going to cause any problem. If they are into lower side of the orbit, then we can give them a boost so that they can enter in the Earth's atmosphere. And as they enter in the Earth's atmosphere, they will burn up and they will completely be exhausted. Even if some part is left, we will have to ensure that as they were falling on the Earth, they are going to fall somewhere into some ocean. There is a place in Pacific Ocean which is again called graveyard of satellites, because whatever part is left has not burned up, it is going to fall somewhere in Pacific Ocean. So we'll have to do something like this. We'll have to arrange something like this. So satellites are also debris if you do not remove them once they have fulfilled their objective. But when I'm using the word debris, I'm specifically talking about two types of debris. You have debris which looks like sand particles. Think of all of those explosions. They will produce a lot of smaller fragments. But you also have debris which may look like this or even bigger than this. So debris of 15-20 inches diameter. And these debris, they travel with very high speed. Their speed often will be 5 times, 6 times, 7 times speed of a bullet as it comes out of a gun. So even this object, think of this metallic object of 10-inch diameter, uh, and then it is traveling with, let's say, 5 times speed of a bullet, and think of this collision with a satellite or a space station or a telescope, and think of the damage it can cause. So that is why space debris is a serious issue, that you have millions of those smaller pieces which I talked about, the sand particle, but also few thousands of particles which are of larger size, of larger diameter. And smaller particles can also cause some damage. For example, जो International Space Station के जो windows हैं, they need to be replaced after every few months, because those smaller particles, they keep corroding that window. So that because of corrosion, windows need to be replaced. But the actual danger is of those large pieces of debris, because they travel with very high speed, and if they go and collide it with any of these space missions, then that is a huge damage, because space missions are very, very expensive. And this issue is only increasing day by day, because more and more agencies are launching more and more satellites into space. Two type of orbits particularly face a lot of problem. That low Earth orbit, particularly that distance from 400 to 800 kilometer, where the satellite concentration is the highest, first, and second, those low orbit, low inclination geosynchronous orbit, including geostationary orbit. They are also very crowded. So these two type of orbits particularly are facing this problem of space debris a lot. What can we do to tackle this? I will come to this part, but पहले आप ये लिख सकते हो, whatever we have discussed. Space debris are orbital junk. Space debris are orbital junk revolving around Earth with very high speed. Revolving around Earth with very high speed. There can be natural debris. There can be natural debris such as micrometeorites, smaller natural objects. Natural objects, we haven't produced them. They are fragments of some other body, some asteroid, something else, and orbiting around Earth. Now, we cannot do anything about it. Like, they will exist irrespective of what we do. The problem is man-made debris. Write down. There can be natural debris such as micrometeorites. However, currently, this has emerged as a serious issue in space exploration. This has emerged as a serious issue in space exploration due to high concentration of man-made debris. Due to high concentration of man-made debris. The major sources are write down in bullet points: fragmentation of spacecraft and rocket bodies. Fragmentation of spacecraft and rocket bodies. Fragmentation of spacecraft and rocket bodies. So this can be because of accidents, rocket upper stages exploding, things like that, or satellites colliding, spacecrafts colliding. Second, upper stages of rockets. Upper stages of rocket. Third, defunct or outdated satellites. Defunct or outdated satellites. Defunct, D-E-F-U-N-C-T. Defunct no longer in use basically. And I should also tell you here, I will repeat this, that the defunct satellites, ideally they should be removed. If they're in low orbit, then they should be given a boost towards Earth so that they burn up in the atmosphere. If they are into higher orbit, then they should be given a boost so that they can be placed into even more higher orbit of 45,000 kilometers called graveyard orbits. And next, one more point you can add. Anti-satellite demonstrations. Anti-satellite demonstrations. Let me explain this. A lot of countries in past, including India, they have demonstrated that they are capable of destroying a satellite into space. So till now, it has been done on your own defunct satellite. So there is a defunct satellite of ISRO. DRDO used a kinetic energy weapon. Kinetic energy weapon का मतलब होता है a weapon which goes on and it collides with very high speed. So it's not exploding, it's not carrying an explosive substance, but as it collides with such a speed that it is going to break apart whatever it has collided with, and in the process it in itself will be destroyed. So a few years ago, in fact, in 2017, DRDO announced a mission called Mission Shakti. And the purpose of Mission Shakti was that we are going to destroy our own defunct satellite. And this was successfully completed. And ISRO became, I think, 4th country to do that. Again, US has done it, China has done it, Russia has done it. That you can destroy your own satellite. And such type of demonstrations will be a message to your adversaries that in the course of war, we are capable of doing this. Right? That in itself is it is part of your deterrent capability, that your adversaries will think twice before attacking you. But many countries have done in the past, and particularly US and China, they have done it many times, and so has Russia. Russia, in fact, just last year it did this anti-satellite demonstration during Russia-Ukraine war, which is going on. So there is a demand right now that such type of demonstration should be banned, but as of now it is not banned. But whenever that happens, this is also going to create lot of debris. तो आप लिख सकते हो इसमें एक लाइन में एंटी सैटेलाइट डेमोन्स्ट्रेशन में, to destroy a satellite from a ground-based weapon, from a ground-launched weapon, to destroy a satellite from a ground-launched weapon. ये चीज इंडिया भी कर चुकी है. So these are the major sources. Few years ago, one of the scientists of NASA, his name is Donald Kessler. Kessler imagined a situation that in future, low Earth orbit will be so dense that one accident will produce debris, large pieces of dense debris, and those debris will go and collide with the nearby satellites. They will produce more debris. They will go and collide with more satellites. So one small accident will lead to a cascading event where every successive accident will produce more debris and will increase the chance of further collision. So this phenomena is called Kessler syndrome. Thankfully, it has not happened till now. But the probability of Kessler syndrome happening is only increasing day by day as we launch more and more number of satellites. आप ये भी लिख सकते हो, this term Kessler syndrome. आप लिख सकते हो, give this subheading Kessler syndrome. Kessler syndrome. A scenario in which a small accident can lead to a cascading event, with series of accidents because of debris, debris, and every accident further increasing the likelihood of collision. Every accident further increasing the likelihood of more accidents. Every accident further increasing the likelihood of more accidents. So in a very short amount of time, think about it, many satellites getting destroyed because of space debris. So what are agencies then doing? What are space agencies doing? Few things which we can do here is that we can be first of all aware about them. We have to be aware about this debris. Particularly, we have to be aware about large pieces of debris. How do we do that? We often use telescopes, we use radar imaging, and we use computers. Even ISRO does that. ISRO has this very dedicated system called Project Netra. That Project Netra includes many telescopes located on the ground. It also includes some radars, Doppler radars. And based on that, they keep tracking the movement of large pieces of debris. But whatever data we have collected, we can analyze that data with the help of powerful computers. And we can know about their future course of movement. And we can predict that if they're going to collide with, let's say, an object which already is in space, perhaps a satellite of ours. And whenever such collision is a likelihood, then we are going to change the orbit for this satellite a little bit, or for our space station a little bit, so that this collision can be avoided. That is the first thing you do, that you are aware about what is happening in space. This particular capability is called space situational awareness. Now, space situational awareness is a larger term, frankly. It includes a lot of things. It also includes knowing about solar winds and flares, all of that. So whatever is happening in space, we aim to know more about it. And how does that affect, let's say, Earth particularly? So this is called space situational awareness. But one of the part of space situational awareness will be to be aware about debris and what type of damage they can cause to existing space missions. So that is the first thing you can do. And here agencies can collaborate together. So ISRO is gathering some information, but ISRO collaborates, or ISRO shares that information with other agencies also. There is a global body for that. Under United Nations, there is a body called Interagency Debris Coordination Committee, where many agencies are part of it, including ISRO, and they share such type of information. But that does not do anything about the existing pieces of debris. Second thing what you can do here is that you can give a code of conduct, or you can apply some global regulations that debris creation comes to a minimum. Jaise, what it will include. It can include, for example, a ban on anti-satellite demonstrations. It can also include that जो defunct satellites हैं mandatorily remove them. It can also include that जो upper stages of rockets हैं, try to separate them at lower altitude so that the final stage of rockets, they can return back in the atmosphere and they can burn up. So all of that can be part of code of conduct. And this is in fact happening as we speak. So many rounds of negotiations are happening that can we find a treaty where all of those things can be actually legally implemented at the global level. But again, what to do about existing pieces of debris? For that, we can send dedicated missions which can collect this debris. We'll try to throw them towards Earth so that they can burn up in the atmosphere, or we will try to destroy them within space itself. But remember, destruction का मतलब यहाँ पे vaporization होना चाहिए, because a larger piece, I try to fragment it further. So from one, I have created two debris. That, it shouldn't be that. It should be complete burning. So for that, we will have to, for example, use laser beam. That very close to a debris, I'm using a laser beam, and with the help of laser, I'm vaporizing a debris. But all of such missions are very expensive, and agencies are not willing to share, come together and share, pool their resources and launch into space debris. So a lot of startups in fact have emerged, and they're asking space agencies that pool your resources, and we are ready to launch a mission so that existing pieces of debris can be destroyed. But I will repeat, there are very few missions which have been launched till now with very limited set of objective regarding destruction of existing debris. आप लिख सकते हो? What can be done? Give this heading. थोड़ा कहाँ पे किसको बूस्ट करने की बात है? सैटेलाइट्स को। तो सैटेलाइट्स डू कंटेन सम फ्यूल। क्वेश्चन ये है कि हम सैटेलाइट्स को बूस्ट कैसे करेंगे ग्रेवयार्ड ऑर्बिट में भेजने के लिए, एटमॉस्फेयर में इंटर कराने के लिए। सो सैटेलाइट्स डू कंटेन सम फ्यूल, दे हैव देयर ओन मोटर। हाँ, तो थोड़ा सा फ्यूल हम हमेशा रखेंगे, दैट आइडियली सम फ्यूल वी हैव टू सेव so that we can give it a thrust either for higher orbit or towards atmosphere. हाँ जी, जैसे in fact I should tell you that just few months ago, or just last month ago, in fact last month if I'm not mistaken, or 2 months ago, one of these satellites, Cartosat satellite, I told you Cartosat, remote sensing satellite. So one of the Cartosat satellite, ISRO returned it back in the atmosphere where it burned up. So ISRO has been doing it for past few years now. that जो भी हमारे defunct satellites हैं, we are trying to burn them up in the atmosphere. हाँ, you had a question. Recycle what? No. So satellites, because as they enter in the earth, inside the earth, they're going to burn up. So, and in any case, the amount of material satellites use per se is not that huge that we have to worry about recycling part. But we do try to recycle rockets, which I was talking about in the last class. Okay. Write down few things here. Give this heading, what can be done? What can be done? The first is space situational awareness. अब इसमें एक लाइन लिख लेना, this is a larger term. This is a larger term. This is a larger term which signifies being aware about outer space, being aware about outer space, such as solar wind, space weather, and even debris, अब इसमें लिख सकते हो, फॉर एग्जाम्पल इसरो हैज लॉन्च्ड अ डेडिकेटेड मिशन, इसरो हैज invested into a dedicated mission. ISRO has invested in a dedicated mission called Project Netra, which aims to know more about debris and the possible impact on space missions, which aims to know more about debris and the possible impact on space missions. इसी में आप एक लाइन और ऐड कर सकते हो, such information often is shared at global stage under Interagency Debris Coordination Committee. Under Interagency Debris Coordination Committee. This operates under United Nations. Interagency Debris Coordination Committee. तो ISRO इसका member है. ISRO is a member of this organization. Right on next point. A code of conduct can be adopted. A code of conduct can be adopted to minimize debris creation, to minimize debris creation, for example, ban on anti-satellite demonstrations, ban on anti-satellite demonstrations, removing defunct satellites, removing defunct satellites, removing defunct satellites. And one more point you can add. Third point, dedicated missions to destroy or remove existing debris from space. Remove existing debris from space. I can name few, but I don't think you need to remember them because they're not part of current affairs. ये 2-3 साल पुराने सारे कुछ missions हैं. Japan launched a mission called ELSA-D. Then there was a mission few years ago launched by a university in UK. But this university got funding from many of the space missions, many of the space agencies. The name of the mission was Remove Debris Project. No, 2 separate missions. I'm giving you examples of some of the past missions which has been launched to demonstrate the capability that can we destroy debris in space. One of that mission was ELSA-D, which was launched by Japanese Space Agency. Another mission was Remove Debris mission that was launched by University of Surrey in UK. I will repeat, I don't think you need to remember them. Remember them, those things which are in news. अगर मान लो right now in, let's say for example, last few months, although there has not been any dedicated mission in last few months, but if there are future missions to remove debris, then definitely know more about it. That who has launched it, what are the objectives of it, things like that. So update this information from current affairs. These are some of the past missions which have been launched. The biggest challenge is not just technology, but also the economics part. That these missions are very expensive and countries and agencies are as of now not willing to cooperate together. They are willing to cooperate in terms of knowledge, but not in terms of resources. So ideally how this will work? Ideally, for example, let's say all agencies are cooperating, but जिस agency का stake जितना ज़्यादा है, they have to invest more money into it. For example, NASA has a lot to lose. SpaceX has a lot to lose because of space debris. Even ISRO has to lose, but not as much as what NASA has to lose or what European Space Agency has to lose. So the goal here should be that agencies should take this common responsibility and they should launch then joint missions together to destroy existing pieces of debris. That is not happening as we speak. Any questions till now in whatever we have discussed? This is completion of this entire discussion about space technology. I will repeat, nowhere I can claim that whatever I have discussed is enough. You need to update this information, update topics from current affairs. My hope here is that whatever we have studied, that will help you in comprehending topics from newspaper, and you will understand the significance of a topic for both prelims or mains examination. So that is my hope. But for that, you will have to do a lot of hard work, right? Haji, you had a question. It does lead to. So the question is that, does it contribute to marine pollution? The answer is yes, it does contribute to marine pollution, without a doubt. The only saving grace here is that there are so many other sources of marine pollution. The plastic which you consume and throw it on the road, that thousands of kg of plastic gets deposited into ocean every day, forget about month or year. Or the shipping industry, which it causes, all the marine pollution it causes, or the coral reefs as they are getting destroyed. That impact is much, much more compared to the occasional satellites or the fragments when they fall in the ocean. But yes, technically the answer is yes, the space debris or rocket fragments, they do contribute to marine pollution, without a doubt. once again, anti-satellite demonstration. Of course, it's not that difficult, frankly. You have to have a very precise attack. That you have a satellite revolving around Earth. You are launching an attack from somewhere on Earth in a way that it goes on to hit this satellite while it is revolving. So you have to have very precise information about where the satellite will be from the time when you launch your weapon, and they both have to collide each other. So we can do that. We have this capability. So DRDO has this capability that it can destroy a satellite. And for that, by the way, when DRDO did that, it did not even use some sort of bomb here. That it's not an explosive substance which went on to cause an explosion in the satellite. It simply was a kinetic energy weapon. Kinetic energy weapon means that something colliding with such high speed that both of those things are destroyed. So this is what was done by DRDO under Mission Shakti. And all such demonstrations, they will be called anti-satellite demonstrations. Any other question if you have? I will give you a handout about it. Yes. That हमने क्या लिखा था? Sources of debris में हमने लिखा तो था कि one of the source of debris will be anti-satellite demonstrations, right? Give the next heading, nuclear technology. I briefly wanted to explain the organizational structure of Department of Space. Do not need to write anything here. Few things you should know here. The Prime Minister, under Prime Minister you have Department of Space. That is the first thing which you need to remember. The Department of Space does not work under any ministry. For example, you do have at least 3 different ministries or 4 ministries with some bearing on science and technology. You have a ministry called Ministry of Science and Technology. It is literally called Ministry of Science and Technology. Then you have Ministry of Earth Sciences. But Ministry of Earth Sciences deals with polar science or ocean science and weather prediction, all of those things. Then you have Ministry of Information Technology, Electronics and Information Technology. That deals with IT technology, right? And then you also have Ministry of Environment, Forest and Climate Change. And that collaborates very closely with, let's say, Department of Space or even other ministries. So I do think that these 4 ministries have direct bearing on contribution to science and technology in India. The most important is Ministry of Science and Technology. But apart from that, you have other departments. So you have Department of Space, but that does not work under Ministry of Science and Technology. It works under Prime Minister. Similarly, Department of Atomic Energy, which I'm going to discuss in the next topic, that also directly works under Prime Minister, does not work under any ministry. So ISRO operates under Department of Space. That is the first thing. ISRO has then many centers. One of the most famous here is VSSSC, that Vikram Sarabhai Space Center. It does so many things for ISRO. But there are many more centers. We do not have to talk about that. I wanted to talk about these 3 bodies here. So you have 2 central public sector enterprise here. One is called New Space India Limited and another is called Antrix Limited. These are companies. These are public sector companies owned 100% by Government of India. And they both operate under Department of Space itself. जैसे Antrix का काम क्या है? Antrix Limited जो है उसका काम क्या है? that जो भी commercial deals होंगे ISRO के, जैसे ISRO does launch many private satellites of other countries. So जो भी commercial deals होंगे that will occur often after negotiation with Antrix. And जो New Space India Limited है, that is also a PSU that makes all of these rockets which we have talked about. For example, PSLV or SSLV, इसका जो exclusive production है, that is done by New Space India Limited, and it is also contributing in production of LVM-3 or GSLV Mark II as we speak. This body also collaborates with private companies. That जो collaboration है, that let's share our knowledge, exchange our knowledge. So New Space India Limited does that also. And one more body which you should know about here is this body called InSpace. And now InSpace is one of the most important body here also, that Indian National Space Promotion and Authorization Center. And InSpace is a regulatory body. Jaise, we have allowed private sector participation into space. That in itself, it's something you should know, that in 2020, Government of India allowed private sector participation into space. But space has a strategic arena also. Space, we use space technology for national security also. So regulation is very important. So InSpace is a regulatory body. And the purpose of this regulatory body is that private companies, they do not feel differentiated. जैसे गवर्नमेंट ऑफ इंडिया के अगेंस्ट एक जो बहुत बड़ा क्रिटिसिज्म हमेशा ये रहा है, दैट चाचा भतीजावाद, दैट इफ यू नो सम मिनिस्टर then you get to open your business, you get a preferential treatment. Every department you go and you witness that with your own eyes, that you have to know somebody. The moment you know somebody, आपके लिए काम आसान हो जाएगा. If you do not know that, भागते रहो, दौड़ते रहो, all of that thing. So the purpose of InSpace here is that there should not be any differential treatment among private companies. जैसे ISRO is cooperating with private companies a lot here, that ISRO के जो facilities हैं, they will be utilized by these private companies to launch their, let's say, their own rockets. जैसे जो स्काई रूट कंपनी के बारे में मैंने भी बताया, या जो अग्निकुल कॉस्मोस है, they are using ISRO facilities for their testing and finally they will also use it for launches. But it shouldn't be a differential treatment. It should be more about the capability and the skill which you have, rather than if you know somebody in ministry. And this is where InSpace comes into play. So InSpace also works under Department of Space, but it is independent of ISRO. So both ISRO and InSpace, they are under Department of Space. The purpose of InSpace here is that जो regulation है, it is not differential, and that regulation is transparent and it is also predictive. Predictive का मतलब क्या होगा? That आज government ने कुछ rule बनाया और अभी elections हो रहे हैं, मान लो government change होती है, and then new government will say that ठीक है, those rules will not be applicable. This is another problem which India faces, that in the political battle of parties, the country's economy suffers, the country's progress suffers. So whatever the previous government did, we are going to remove all of that. And the political situation in India is like this, that there is no cooperation between opposition and party in power right now. Ideally, that should not be the case for any nation. Definitely should not be the case for India, but we are suffering from this. So the goal of InSpace here is that regulation also should be predictive. So this is also an important body which we should know about. So a very basic rough idea about the organizational structure of space sector into India, you should have in your mind. Let me ask a question from nuclear technology now, that when you think about this word nuclear technology, then what comes to mind generally? What do you think about it? Nuclear fission, fusion, atomic bombs, nuclear explosion, hydrogen bombs, all of those things. Anything else apart from the energy production, apart from the explosive part, or apart from hydrogen bombs or nuclear bombs? Anything else which comes to mind? Okay, so we are talking about, I'm specifically talking about the technology part. That what type of applications come to mind when we think of the word nuclear technology? Okay, electricity production with the help of nuclear reactor, that also comes to mind. That's a good point. What if I tell you that nuclear technology has applications in our day-to-day life? It has applications in food processing. It has applications in agriculture. It has application in this fire alarm in this room. There is a very good chance that this fire alarm has some aspect of nuclear technology. So nuclear technology is much more common in our life than we think to be. We often think of nuclear technology somewhere there is a reactor or somewhere somebody is developing a nuclear bomb, and we think that this is what nuclear technology is all about. But it is much, much more than that. It has applications in many areas, and this is what I'm going to discuss in next class. So all the topics I'm going to discuss in this topic, in this particular module of nuclear technology. I will again start with the basic science bit. That to appreciate this technology, the amount of information we should be knowing before we can jump to the technological application part. But yes, immediately after this, I'm going to talk about its applications. And I'm going to spend a lot of time, in fact, almost an entire class or even more than a class, on just one application, which we all know about, is how do we use nuclear technology in energy production. And I will be focusing upon two specific type of reactions which happen. One reaction is called fission, and another reaction is called fusion. Then I'm going to explain something called radioactivity. Because without appreciating radioactivity, we cannot appreciate other sets of applications. So now the last part here will be applications in agriculture, or medicine, or even space, by the way. Nuclear technology has applications in space, it has applications in industry, it has applications in defense, in many areas. Carbon dating is an application of understanding of nuclear technology. In today's class, let's only limit ourselves to the first part, the basic science part, that what we should know before we can jump to the technology part. So the word we are using here is nuclear technology, something to do with nucleus, right? So let me go back to what you already know in your school days. I will perhaps add few more information, but a lot of things you already have studied. We have studied about atomic structure, right? We have studied that you have this very dense object which we call nucleus, and around this dense object you have electrons revolving around it, and this dense object contains two types of particles called neutrons and protons. We have studied few basic things about these particles. For example, we know that neutron and proton, they have almost same mass, and we measure such small mass into a unit called atomic mass unit. So neutron and proton has mass of, their mass is about 1 atomic mass unit. Mass ka SI unit is kilogram. If I try to convert that 1 atomic mass into kilogram, what it will be? 10 to the power what exactly? Minus 27. So it will be 10 to the power minus 27 kg. That's a very small value. We cannot imagine 10 to the power minus 27 kg. Technically, both of the mass of neutron and proton is little bit more than 1 atomic mass unit. And technically, neutron is little bit more massive than proton. Very little bit, but it is more massive than proton. But it is very close to 1, and both of them, the mass difference between a neutron and proton is so less that we do not worry about it. So I'm simply going to say that neutron and proton, they both have mass of 1 atomic mass unit. We also have studied that electron has negligible mass. It is not 0, should be very clear. In the same unit, the mass of electron will be 1 by 1831 atomic mass unit. So electron ka jo mass hai, that is 1 by 1831 atomic mass unit. So if I add 1 plus 1 by 1831, that is approximately 1 only. I do not have to worry about mass of electron if I am talking about mass of proton and neutron. But technically, electron is not a massless particle. That is very important. The other fundamental property which we already have studied is about charge. The same way mass is a fundamental property of particles, even charge is a fundamental property of particles. But charge exists in two different domains. You have something called positive charge and something called negative charge. So we have studied that we measure this charge into unit of electron, E minus or E plus. Charge ka jo SI unit hai, that is coulomb. And 1 electron ka jo charge hai, that is exactly what? In coulomb? 1.6 multiplied by 10 to the power minus 19 coulomb. Do not have to remember. Don't worry, don't be scared about all these values. We do not have to remember any of these values. But we have to know that electron is a negatively charged particle with value of 1.6 10 to the power minus 19 coulomb, and proton is positively charged particle with the same value but with the opposite sign. We still do not know why is it so. Electrons and protons share the exact same charge, and we do not have a very good explanation for it. And turns out that in a neutral atom, the number of protons and the number of electrons are exactly same. So every atom is electrically neutral because positive and negative charges, they cancel out each other. So an atom is always and always neutral. The moment you remove electron from an atom, then it becomes positively charged. It has more protons compared to electrons. We call it positive ion. And if I add electron into atom, it has more electrons compared to proton, it becomes a negative ion. So all of that you already have studied in your school days. What about the size? When I use the word atom, let's imagine atom to be of spherical shape. And what will be the size or what will be the radius of this sphere? I'm imagining that atom has some spherical shape. I'm trying to think about that what will be the size of this sphere or radius of this sphere. What will be the range? So it's not femto. If I'm talking about atom, it is not femto, it is angstrom. It is 10 to the power minus 10 meter. So if I have to look at this particular radius here, then this radius here is in the range of 10 to the power minus 10 meter. And we use 10 to the power minus 10 meter as angstrom. It is 1 angstrom. It will be a few angstrom, 4, 5, 9, whatever. But it will be in the range of angstrom, 10 to the power minus 10 meter. And the size of nucleus. So inside an atom, now think of that within a larger sphere of radius of 1 angstrom, you have a smaller sphere inside it. And iska jo ab radius hoga, this will be 1 femtometer. And femtometer is again in the range of 1 femtometer, 10 to the power minus. हमारा ह्यूमन ब्रेन इतने स्मॉल साइज को कॉम्प्रिहेंड कर ही नहीं सकता. कॉम्प्रिहेंड का मतलब वी कैनॉट इमेजिन इट. वी कैनॉट इमेजिन एनीथिंग लेस देन 1/10 मिलीमीटर. फॉरगेट अबाउट ये तो हम 10 to the power minus 10, 15 में जा रहे हैं. If I ask you to imagine 10 to the power minus 4 meter, which is 1/10 of millimeter, right? And if I ask you to now imagine less than that, then your brain will not be able to imagine. So I have no perspective to think about either 10 to the power minus 10 or 10 to the power minus 15. But I have mathematics to my rescue, that mathematically I know that atom is a very small thing. Clearly we cannot see that with our naked eye. Anything 1/100 millimeter we cannot see, and 1/100 is 10 to the power minus 5. And then I'm saying that 10 to the power minus 5 को further divide करो 1 lakh times, and then we go to 10 to the power minus 10, and then further divide this 1 lakh times, and then you go to 10 to the power minus 15. So I can neither imagine an atom nor can I imagine nucleus, but I do understand the statistical difference. I do imagine, or I can imagine in a way that most of the atom is empty. Atom has a very dense space in the center, at the center of it, which we call nucleus. Why dense? Because neutrons and protons, they both are massive particles in front of electron, and all of that mass, so 99.9999% mass of atom is at the nucleus, and that 0.00001% of mass is all of those electrons revolving around atom. This study we have done, this much information we have done. We also have read about that whenever we have to talk about elements, we use this concept of atomic number, and we use this concept of atomic mass. Atomic number is simply defined as number of protons, and since number of protons will be same as number of electrons in each and every atom, so it can also be defined as number of electrons. Atomic mass will be number of neutrons and number of protons. That's very simple because both of them have mass of 1 atomic mass unit. So if I just add the number, mass of one atom will be that much of atomic mass unit. So this is atomic mass, and based on that atomic mass and atomic number, you might have read about terms like isotopes or isobars. Isotope will be a very popular word for me in this entire discussion about nuclear technology. So isotopes are those atoms, they have same atomic number but different atomic mass. I should tell you a few examples. I'm going to give you most famous examples. The first example is hydrogen itself. Hydrogen is the simplest element. This is a way to represent any atom. So let's say this atom is X, X can be anything. We often represent its atomic number with Z and its atomic mass with A. So Z is number of proton and A is number of proton plus number of neutron. So hydrogen has one atomic number and one atomic mass, which basically means that it has no neutron. If I look at the hydrogen atom, it only has one proton and one electron revolving around it. It has no neutron, hence 1 and 1. But turns out that hydrogen exists in two other forms. There is an isotope of hydrogen which has one proton but has also one neutron, and that 1 plus 1 becomes 2. We call this deuterium. And then there is another version of hydrogen which we call tritium, that it has one proton but now two neutrons, and its atomic mass is 3 then. 1 plus 2 becomes 3. So all of them have same atomic number 1, 1, 1, but atomic mass changes, hence isotope. Another very famous isotope is carbon. We all are carbon based life. All of our biomolecules are nothing but made of carbon. कार्बन का जो एटॉमिक नंबर है वो 6 है, एटॉमिक मास 12 है, which basically means it has 6 protons plus 6 neutrons, hence 12. But there is a very famous isotope of carbon which we have read in our school days, that somehow it tells us the age of a particular fossil. That I have collected a fossil, and by measuring carbon 14, somehow it tells me the age, that how old that fossil is. So I'm going to explain in this particular module that how does it tell us the mass, how does it tell us that how old a particular fossil is. And then there is another very famous isotope which I will be talking a lot about, is uranium. So uranium का जो सबसे prevalent isotope है वो uranium 238 है. Uranium has atomic number of 92. The most popular isotope of uranium is uranium 235. But uranium has at least 10 isotopes. You have starting from 230, 231, 32, 33, 34, 35, go to 39, 40, 41. So at least 10 to 12 isotopes uranium has. But these two are the most famous one. I will be talking about these two. So all of these atoms which have same atomic number but have same different atomic mass, we can call them that they are isotopes of each other. Isobars I will not be using per se, but you should know here also that they have same atomic mass but different atomic number. I can again give few examples here. As I gave the example of tritium. Turns out even helium has two isotopes. Helium का जो atomic mass है वो 4 है, but there is an isotope of helium जिसका atomic mass 3 है. So now look at these two atoms here. One proton, two proton. Atomic number is different, but they both have atomic mass as 3. So neither the number of proton nor the number of neutron are same, but their sum is same. So n plus p becomes constant. 1 plus 2, 2 plus 1, both has 3. Or think of carbon 14 and compare that with the most popular type of nitrogen. Nitrogen has atomic number of 7, atomic mass of 14. So 6 protons, 8 neutrons, 6 plus 8, 14. 7 protons, 7 neutrons, 7 plus 7, 14. So this will be called isobars, where I have same atomic mass and different atomic number. I haven't still told you what is nuclear technology all about. There are many reactions called chemical reactions. हम सबने पढ़ रखा अपने school days में. A lot of changes happen at the level of atoms and molecules. Electrons rearrange themselves. There are many chemical reactions which are happening in the name of time. Burning is a chemical reaction. I burn something, and that burning releases the stored potential energy in the chemical bond as a thermal energy. I burn a paper, I get heat. So even though it is energy, but where is that energy coming from? It is the energy stored in the chemical bond of that paper, which is getting released as thermal energy. But burning is a chemical process. आपने गर्मी के दिन में दूध छोड़ दिया, दूध फट गया. That is a chemical change which is happening. That this is now, we cannot drink that particular milk. That is a chemical change. Iron, rusting of iron is a chemical change. So we know that lot of chemical changes are happening. All of the medicines which we use, they are example of some chemical change which we are inducing into a lab. That in a lab, I'm trying to make a particular molecule, and turns out that particular molecule has certain health benefit. So there are a lot of naturally chemical reactions happening, but this understanding of chemical reactions allows us to make various type of substances, and those substances have a lot of utility into different areas. What if I tell you that in none of those chemical reactions nucleus has any role to play? Nothing happens to nucleus. Nothing happens to that proton, nothing happens to that neutron. Only electrons are going from here and there. Atoms are going here and there. But atom ke inside ka jo nucleus hai, nothing is happening to it. So all chemical reactions are nothing but rearrangement of electrons and rearrangement of atoms and molecules. And all chemical reactions, remember, if reaction is happening, it must be because of some force. Without any force, no reaction can happen. All chemical reactions occur only and only because of one force, and that force is electromagnetic force. That you have electromagnetic force operating between two things. Think of sodium, think of chloride. Sodium has to lose one electron to become stable. Chlorine has to gain one electron to become stable. They both are bound to each other with electromagnetic force, and they form that common salt which we call sodium chloride. But all chemical reactions essentially are changes happening at the level of electrons, atoms and molecules, not changes happening at the level of nucleus. And all chemical reactions are guided only and only by electromagnetic interaction. But there are reactions which changes nucleus. There are reactions which changes the particles inside nucleus, those protons and those neutrons. And those reactions are called nuclear reactions or nuclear decay reactions. And there are many nuclear reactions which happen in nature also. They are quite rare. Chemical reactions are much more popular. But there are nuclear reactions which nature, even on Earth. And there are nuclear reactions which we can, the same way we have chemical reactions into a lab setup, into industrial setup, we have nuclear reactions into a lab setup, into industrial setup. And the utility of those reactions for whatever purpose, for agriculture, for medicine, for energy production, that is what nuclear technology is all about. So when I use the word nuclear technology, it fundamentally involves first the understanding of processes which are happening at the level of nucleus. We have no perspective whatsoever. We cannot even imagine that what is happening. But we can understand the mathematics, we can understand the science, and that understanding of that knowledge allows us to now utilize those changes. And even though those changes are happening at nuclear scale, but we can utilize that in so many different areas. And that is what nuclear technology is all about. And I will talk about that in more detail in next class. In next class, I'm also going to conduct a quiz of 25 questions from the topic, जो space technology अभी हमने पढ़ा है, only and only from space technology.